Triangles. So the reason why we talk about triangles so much in geometry is because it's the simplest shape, right? It's instead of doing quadrilaterals where they can do all sorts of crazy things, triangles have no diagonals. They're the simplest shape, and therefore that's what we do most of our study around, those big ideas about those shapes, and then we kind of to apply them to other shapes. But at any rate, so this is all about congruent triangles and proving two triangles are congruent. Now, if we already have congruent triangles, they have 3 pairs of sides and 3 pairs of angles, right? 6 parts that are congruent. And then the thing is, though, is do we need all of those congruent parts to prove they're congruent? Like, if they look congruent, can we actually say they are congruent? We have to prove it. And so there's this whole idea of, like, innocence and guilt, you know, just like the justice system, law and order, blah, blah, right? So there's the idea of proving things are actually true that we kind of play with in this unit. And the deal is there's 6 different parts, and then there's 5 different ways, and there's statements, and there's reasons. So just take it one moment at a time. We're not going to expect you to fly right away, but I have kind of made sure that the packet is kind of looks like it's short, but it's because we're going to have practice days pretty often in between to make sure that we understand the concepts, okay? Because it's kind of like the first time you have to write like an essay. You're like, what? Or write a poem, what? You know, you're just like, wait, yeah, I need modeling. I need some examples to look at. What is your expectation for me, okay? So those kinds of ideas. All right, so we have 5 congruence theorems to play with today. Everybody's back in the room except for me. Join me on page 3. So I know so part of the problem with quarter 1 is that we spend a lot of time being like, you must mark things this way, right? Yeah. You must mark it this way, you must mark angles this way, blah, 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 blah. Those ticks mean what? Blah, 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 blah. And that's because as teachers, we know we're taking you to this, okay? So marks, whether they be arcs for angles or tick marks for sides, now play a really important part in how we interpret where we're going with a pair of triangles. So let's just remind ourselves of the following. If I want to mark congruent angles, I'm going to use angle marks or arc marks. That's what I meant to put. It rhymes. Arc marks. And we'll do an example of that. Arc marks. And if I want to mark congruent sides, I'm going to use tick marks. Okay. And then here we have an example of what I just did on those 3 slides, but now it's in your notes, and so try to pay a little bit more attention. If we know 2 triangles are congruent, they're telling me triangle ABC is congruent to triangle DEF. This is what we did then last unit. ABC, triangle DEF. We were able to do the following. We were able to line those letters up and then talk about how we have corresponding parts, pairs of corresponding parts that are congruent. So there are 3 pairs of angles and there are 3 pairs of sides. Okay. So, for example, and I'm just going to use some shapes to kind of designate the different angles that go together. So, angle A has a single arc. It corresponds and is congruent to angle D, which has a single arc, right? They're lined up. Angle B has a double arc, and it corresponds with angle E, which also has a double mark. Okay. Angle C has triple arcs, and so does angle F. So there's 3 pairs of angles that are guaranteed to be congruent. We can do the same thing with sides. So this, I'm going to highlight all three sets of sides. It's already marked with the 1s, 2s, and 3 tick marks. But basically, we want to make sure that we can really see and understand side AB corresponds and is congruent to DE, right? They have singles. And then BC, which has a double, is congruent and corresponds with EF. And then the last one is AC corresponds and is congruent to DF. All right. And maybe you figured it out as I was highlighting there's been some sort of a reflection involved in this because the orientation has been reversed. So we can tell that rigid motions have been used, and that's how we have these two triangles that are congruent. Okay, so now, ready to go to the next part? Now we take away the fact that the two triangles are congruent, and we're trying to prove triangles are congruent. We have to prove them. What? So the question becomes, how do we do that? How do we prove two triangles are congruent? And so you might be like, well, I'm going to get out my ruler and I'm going to measure this one and I'm going to measure that one. And you're right. We can do that if we have access to those tools, but we don't always have access to those tools. And if we don't want to we want to be able to say, hey, any two triangles that have these things are going to be congruent. So when we do measurements, it's specific, right, for that particular triangle and that particular triangle, right? We want to be in proof, we can generalize. Like that's why we know that like a squared plus b squared equals c squared. It always works. It's been proven that it always works. Like we can prove it with numbers, but then we have to keep on doing it with numbers. We can prove it with other ways, and then we know it's true forever. All right, so these things that we can prove are called theorems, all right? And there are 5 of them. So I'm literally just going to read through them first, okay? The first one is called side, side, side. Mathematicians inherently lazy. We're going to write SSS, but what comes out of our mouth? Side, side, side. Okay, you good with that part? Then we have side, angle, side. Angle, side, angle. Angle, angle, side. And then we have the last one, which is called hypotenuse leg, which can only be used for right triangles. Now, right triangles can occur up here as well. It's just that if it's a right triangle, we might be able to use this one. Non-right triangles can't use that one. Okay, so that's the first thing. So now let's try to understand what's going on. We had up here 6 things, right? 3 pairs of angles and 3 pair of sides. But notice in the theorem, it's just the 3 sides. That's right. Because if this side is congruent to that side, so mark that on your picture. And if this side is congruent to that side, mark that on your picture. And if this side is congruent to that side, then I don't need to know anything about the angles at all. So notice how I haven't talked about any of the angles. I don't have to know anything about the angles. If I have 3 pairs of congruent sides, then I can guarantee those triangles are congruent. Okay, that's method number 1. Here we go. Next method. This one says side, angle, side. So notice that the angle is in between, literally, the 2 sides. Now, I'm just randomly picking 2 sides at an angle on the picture. Does that make sense to everyone? Like, you can do it with any 2 sides, but they have to be corresponding. So, for example, I can pick this side and this side. If those 2 sides are congruent to each other, and then if this side and this side are congruent to each other, and the angle that's in between them, notice I'm marking it with an arc, if those three pairs of things are there, I know the triangles are congruent. So watch what I'm just going to do on the outside of the triangle here. Side, angle, side. See how that works to help me figure out what I'm doing? And obviously I could write it on the other one too. So this one is two sides and the included, so there's a new vocab word, included angle. It means that it's the angle in between two sides. Okay? All right. Let's do one more. Okay, angle, side, angle. So guess what's in the middle this time? The side. All right, so here we go. I've got this angle congruent to that angle. I got an angle. And guess what? I'm going to say it's this angle, double arc, is congruent to this angle with a double arc. If I have also the side in between those two angles on both triangles, then I can prove those triangles congruent by angle, side, angle. Okay? So it's two angles and, so we get to use that vocab word again, the included side. So we've used the word included twice now. So let's make sure in the side column where we like to write down some things. Included means in between. So we've got three ways now. Side, 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 angle, side, angle, side, angle. Now we're going to do angle, angle, side. So this time it's two angles. So let's go ahead and do it this way. Two angles, right? Just like we did on the picture up above. But it's not the side that's in between them. Okay, so I'm just going to pick one of the other two sides. So I'm going to say that this side is congruent to that side. So you notice that this is different than that, right? Okay. Question?
Does it matter what angles you do?
So right now, I'm just trying to describe what's going on. We're eventually just we're going to be limited by the information that we have, and so we use what they give us. Does that make sense? So I'm just randomly picking things so we can mark pictures and kind of start the discussion. It's hard to get this party started. But this is two angles, and then you could say, and the non-included side. And so as I'm reading around the triangle, I can read angle, angle, side. Now some kids might read side, angle, angle. That's the exact same thing as angle, angle, side. Does that make sense to everybody? Okay. Now, before I do the last one, this is what I want to kind of talk about. Do you see how I've always done, and I picked them myself, so I picked corresponding angles. So it doesn't work if, like, say I pick this, or say I have this angle and this angle, and I have this angle and that angle, right? So I've got my angles. But if I have this side and then I have this side, so even though this one is angle, angle, side, and this one is angle, angle, side, do you see how the sides don't correspond? So this does not work. And that's because, and it's right up here, the congruent sides and or the congruent angles need to be corresponding pairs. Okay? So these are not corresponding sides. And so that's doesn't work. Okay? So not everything works. And that's why this becomes difficult, because we got to figure out what works and what doesn't. Okay, so now the last one is for right triangles. If we have right triangles, we might not have right triangles, and we might have right triangles that have side, 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 right? It just depends what you have. But if you have a right triangle, then you can call this opposite side the hypotenuse. Do you guys agree with that? Okay, so in the language of triangles, then we can call the opposite side the hypotenuse. So if I have two right triangles where the hypotenuse is equal to the hypotenuse, right? And then a pair of corresponding legs are congruent. So this is leg. Then those triangles will be congruent. And we all know the word hypotenuse. Okay, the other two things are called legs. So once again, if this one had this leg and that one had that leg, it wouldn't work. Okay, so you have to have pairs of corresponding. Okay, we're now going to take a pause, and I'm going to review all this via a video. So before we turn the page, we're going to try to shove this through your head one more time. Does that make sense? Yep. So it's an interactive video, which hopefully then, like visual moving things. So hopefully then it will be easier to understand once we go to the next part. Cool? Okay, so here we go. Video is up. Boing. We go to the next page, I believe. Oh yeah, here we go.
What's up, everyone? Welcome to this lesson where we're going to explore the different triangle congruence theorems. So let's start out by asking the question, what does congruence even mean? We like to think of it as this equal sign with the squiggly line over it, but let's just take a few moments to really conceptualize what congruence means, especially in terms of figures. So let's look at a running shoe. If I can somehow duplicate this running shoe and make an exact replica, I would say that these two shoes are congruent because they are exactly the same size and shape. Now, even if I change the color of one of the shoes, or I rotate it around a certain number of degrees, it's still congruent to the original sneaker because it's the same size and shape. And we want to extend this kind of thinking now to comparing triangles to see whether or not they are congruent. If their corresponding sides and angles have the same measure, then we can say that the triangles are congruent. And this applies even when the figures don't have the same orientation, and visually it's not so easy to tell whether or not these triangles are congruent, and this is where our theorems are going to come into play. So the goal of this lesson is to help you to understand why the theorems that we use prove congruence, and how to know which theorem to use in a particular situation. So here are the 5 triangle theorems with their abbreviations. We have side, 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 angle, angle, side, angle, angle, side, and hypotenuse leg. So now we're ready to go ahead and explore each theorem individually. Now the side, side, side triangle congruence theorem states that if in two triangles we have 3 pairs of corresponding sides that are congruent to each other, that means that they have the same length, then that's enough information to say that the triangles are congruent to each other. Which again just means that both triangles are exactly the same size and shape. So in this instance, we can use the side, side, side theorem to conclude that the triangles are congruent and that their corresponding sides and corresponding angles have the same measure. And remember that this relationship is still true even if the figures have different orientation. Our next theorem is side, angle, side. Now for this triangle congruence theorem, we start with a pair of corresponding congruent sides in 2 triangles. We also have a pair of corresponding angles that are congruent and another set of corresponding sides that are congruent.
Okay. Do you see how there's only 3 things there? Do you see how literally there is only one possible line that can finish the triangle, right? That's why you only need 3 things. Because you're going to guarantee yourself that the triangles have to be congruent with only those 3. Okay? So that happens on the rest of them, but it's a little bit more interesting to see that when we have angles and sides mixed. Okay, thing.
Corresponding sides that are congruent. Now see that the letter A is in between the 2 S's in the name of the theorem? This corresponds with that congruent angle being in between the 2 congruent sides. Now when this is the case, we have enough information to say that the 2 triangles are congruent by using the side angle side theorem. Our next congruence theorem is the angle side angle theorem. When we have 2 triangles with a pair of corresponding congruent angles, a pair of corresponding congruent sides, and another pair of corresponding congruent angles, we have enough information to prove congruence using angle side angle. Now it's important to notice that the congruent side is in between the 2 congruent angles. And now we can visualize that when this is the case, we have enough information to prove that the 2 triangles are congruent by angle side angle, which means that all of their corresponding sides and corresponding angles have the same measure. Now our next theorem is very similar to the one that we just looked at, which was angle side angle. This one is called angle angle side. Now when in 2 triangles, we have a pair of corresponding congruent angles, along with a second pair of corresponding congruent angles, as well as a pair of corresponding congruent sides. Now we don't want to confuse the last theorem, angle side angle, and this theorem of angle angle side, because both of them involve 2 congruent angles and 1 congruent side. The difference is that in angle angle side, the congruent angles are consecutive, that is that they are one after the other. And then the congruent side is next to them instead of in between them. Now even though the order is different, we still have enough information here to prove that these 2 triangles are congruent, which means again that their corresponding sides and corresponding angles have the same measure. Now our final congruence theorem is kind of a special case. It's called hypotenuse leg, and it applies to right triangles only. So let's start out with the key feature of any right triangle, and that is a right angle. Now we know that the hypotenuse of a right triangle is its longest side and is always opposite the right angle. So this congruence theorem says that if the hypotenuse in both right triangles are congruent, and if a leg, which is one of the other sides, are congruent, that is, they have a pair of corresponding congruent sides, then that is enough to say that the 2 triangles are congruent. Again, which means that the triangle's corresponding sides and corresponding angles have the same measure.
Okay.
So now that we've covered the 5...
Okay, so I'm going to pause there. We're going to turn the page. There's a little bit more to this video, but I want to do it in a little bit, okay? And I want to make sure that the whole day is not lecture notes, but we have to get through like these first parts so you guys can try practicing figuring this angle side things on your own, right? Okay, so when you turn the page... Okay, and actually you've turned the page, I haven't turned the page. First of all, do you notice that these are so easy to see because they've literally just been translated from each other, they're separated, do you know what I mean? They're like so nice and pretty, but that's not usually how things happen, right? When we turn the page, we see triangles that are back to back, right? And we see triangles that have been rotated. But that doesn't mean they still don't have 3 angles and 3 sides. They still do. So there are a couple things that we might be able to mark in a picture already that we have as congruent sides or angles just because the picture is the way the picture is. The second one is the one that you guys are already really familiar with. If I have 2 lines that intersect, isn't this angle guaranteed to be congruent to that angle?
Yes.
Yeah, what are those called? Vertical angles. So when lines intersect, right? So when lines intersect, vertical angles are congruent. Sorry. And so even though like these triangles are twisted around, this angle is congruent and corresponds with this angle, right? You guys agree with that part? So when, like, I might be able to do side angle side on this. I don't know. Just depends what other information I have. Now the one up above is a little bit different, and you've never heard of this thing called reflexive property. What reflexive means is I have something that belongs to both triangles, and of course then it's equal to itself, right? So for example, in triangle, if I look at the triangle over here, this is triangle X, Y, Z. Oh, actually this one over here is X, Y, Z. Do you guys see that? X, Y, Z. So I'm just going to do a quick outline on it. And then on the other side, I have triangle, and this is where you want to try to do the drawing around the triangle the same way you did the other one. So I started at X. So I'm going to start at X, and I went out to Y. So this time I'm going to go out to W and come into Z. So it's X, W, W, Z. Did I say that right? Yes. Now, do you see how this one has XZ and this one has XZ, right? Both triangles have a shared side. So guess what? We can put in, instead of doing a little like tick mark, we have a special tick mark. We put an X on that shared side. So we mark it with an X, and essentially it means that this side is congruent to that side. It literally is kind of like the same idea of what we put here. And so what are reflexive sides? It's a shared side. It belongs to both triangles. And then the other thing we do is we mark it with an X. And the key with these two things is we have to be like a detective, and we have to see these congruent parts and mark them. So sometimes they will tell us information, and sometimes you need to see information. So this is kind of an example of that. So here's a whole bunch of pictures of triangles that may or may not be congruent. Okay, so let's look at the first one. Do you guys see a shared side or vertical angles in the first triangle? Set of triangles, right? You guys see a shared side? So you put an X on that. Okay, so now that that is on there, I have like this side, which corresponds with that side, right? But I also have this side, which is corresponding and congruent to that side. And I have this side corresponding and congruent to that side. Can I prove those triangles congruent? Yes, I can by using the theorem side, side, side. Okay, so that's what we're doing. We're looking at the picture, and based on the picture and the markings and the order of them, can I figure out what of the 5 theorems I'm going to use? Okay, so let's look at this. Do I have vertical angles or a shared side? Shared side. So I'm going to put an X right here. Okay. Now, do you see how I marked both triangles? You don't have to put all these S's and A's everywhere. I do it at least on one of them when I'm getting started to make sure I understand what's going on. So here is a side, and is that congruent to this side over here?
Yes.
Yes. And then it's followed by an angle right? Which matches that angle there. And then I have a side here. So can everybody see side, angle, side? Yeah? So this one's side, angle, side. And so is this one, right? They have to be the same in both triangles for it to work. I just don't have to put all the S's and A's everywhere. It just gets a little messy. Okay, let's look at this next one. Oh, not a shared side, but do we have some vertical angles?
Yeah.
Yes. So I'm going to say, hey, this angle is congruent to that angle. Okay, so everybody sees a set of angles. What else do you see that's marked?
There's the one angle that we marked, and there's the side.
Okay, so now we have a side, a set of sides that's marked.
And then we have another angle,
So do we have, and we have another angle at the end.
so ASA, angle, side, angle.
Angle, side, angle, because the angles, and then the side is in between. Does that make sense?
Yep.
Okay, so this is going to be angle, side, angle. All right. So let's go to the next one. So notice how sometimes, like, do you see how these single arcs are kind of diagonal from one another? Like these ones are diagonal from one another, but look at these arcs. These angles are the two that are congruent, right? But I have angles, and I have angles down here, and I have a shared side, right? So I have angle, side, angle. Yes?
Same thing again.
Well, so is this angle, side, angle? Angle, side, angle.
I think it is.
Angle, side, angle. Side, angle, side. Huh. I was looking for an angle, angle, side. I guess I don't have one. Angle, side, angle. I'll be all right. I thought I had an angle, angle, side. I do not. Okay, great. Here we go. Da, da, da. Oh my God, what kind of triangles do we have? Right triangles. Now, so this is the deal. You might start by saying, oh, I've got angle and side and side. But notice how it's not angle, side, or it's, you know what I mean? Like, do you see how it's not side, angle?
Hypotenuse leg.
Do you see how it's a mess? And in fact, oh, kids, what happens when you go like that? What do I spell? Do you guys want me to write it?
Yeah. It's okay, Mr. Up. You can do it.
What is that? Can we? That's a bad word.
Oh, I thought you were trying to say it.
Can we do it?
Yeah, we can.
We're not allowed to do that. You cannot do angle, side, side. It's a no-no. So guess what, though? We can, and this is why it only works for right triangles, because we have a right triangle with a hypotenuse and a leg. Okay?
Leg.
So this one is going to be hypotenuse leg. So the thing that we just saw is that side, side angle. Notice I just wrote it backwards. Is a no-no. Okay, we'll figure out more about that tomorrow. Okay, now, this is the deal. Let's look at what we have here. We have an angle that goes with an angle. We have a side that goes with this side. And then we have that, right? Which is also a set of sides.
Angle, side, side.
Is it?
I think.
So you have to go in order. Do you see how, okay, so we have, this is our triangle, right? So I have angle, side. I don't have the angle here, do I?
No, but you have the side of the next one.
Okay, angle, side, side spells what?
S.
Yeah, can we get to do we get to do that? No, so this cannot be proven congruent. We do not have enough or correct information to prove. We will see more of that mañana, okay? So this is also bad news bears here, people. Not good. Excellent. So this is where we're going to take our pause in our notes.